Now let me let's look at the third case, e to the exponential multiplied to the cosine x. All right, so here it is. And we'll be using this second derivative product rule. I think it's reasonable to see that if you try e to the 2x cosine 3x, and it'll pick up right here, and have to differentiate it one time, you will have this one showed up again as we differentiate that part. If you differentiate it 2 times, again, so this part will definitely part of the left-hand side if you stick this one into this operator. So we'll do that. Here is e to the 2x times a cosine 3x. So the first part is differentiating 2 times, so let's differentiate it 2 times using this formula here. So if you differentiate that one 2 times, it's a 4 times e to the 2x, and cosine 3x not differentiated, and there is this Pascal's triangle number, and if you differentiate this one 1 time, it's e to the 2x, differentiate this one 1 time, it's a negative 3 sine 3x, right? And if you differentiate that 2 times, that's this part here, it's negative 9 e to the 2x cosine 3x. That's only the second derivative, so if you differentiate it 1 time, it's the next term, so that will be 2 times e to the 2x cosine 3x. Differentiate that one, it will be negative 3 outside, e to the 2x sine 3x, the chain rule, and plus the whole function itself. That was just a first derivative, so e to the 2x cosine 3x. Right. So everything is e to the 2x cosine 3x or e to the 2x sine 3x. Let's collect the coefficient of e to the 2x and cosine 3x. So those are these coefficients, 4 and the 9, negative 9, and negative 2 and positive 1. So when I did the arithmetic, it all together was negative 6 e to the 2x cosine 3x. If we look at the sine, here's negative 12. That's a sine 3x, e to the x. And here's another one, that's together is positive 6. And that's it. So mistake, this is not positive 6. This is just a positive 3, right? It's positive 3, so this is negative 9. It's negative 9 e to the 2x sine 3x. All right, so that's what it came out. So we have this e to the 2x cosine 3x, that's what we wanted, but there's another term, the sine 3x showed up. So you try, of course, the other one, kind of come in pairs. So if you try sine 3x, we'll have a similar result like that. And with this cosine 3x and sine 3x, and you can combine it to get rid of sine 3x. So when we did that, it turns out it's negative 6 e to the 2x sine 3x plus 9 e to the 2x cosine 3x. That turns out, if you go through exactly the same thing, that turns out that's the answer. So now how are we going to get rid of the sine part, and it's 6 and 9, and the least common multiple is 18. So let's see how we're going to get 18 here. I'm going to multiply definitely 2 there to get 18. 2 times e to the 2x and cosine 3x, and that's going to be 18 here. But here's a 12. That's going to be the coefficient there. By that part, it's going to be negative 18. So that's the result. After we multiply 2 there, we're going to multiply 3 there. 3 like that, e to the 2x sine 3x, and that's going to be 3 multiplied there, and negative 18, like that, and 3 is multiplied to this one, so it's going to be 27, like that. So if you subtract the second line from the first line, this will cancel the sine 3x part. So we have L of altogether, L of 2 times e to the 2x cosine 3x, that's the first line. Linearity, we do everything inside L. Subtracted it, e to the 2x sine 3x is inside this operator. So if you subtract these two, you get together it's negative 2039 e to the 2x cosine 3x. That's what we get. Right, I corrected the cosine part. I'm going to move it slightly up here. So all we have to do now is divide both sides by negative 39. So we have a particular solution now, negative 2 divided by 39, e to the 2x cosine 3x, and this part will be 39 goes to the denominator, become positive 3 over 39. E to the 2x sine 3x becomes just one copy of this part in here. That's how you find the particular solution for this part. Let me show you this overall calculation again, and this is how we started the problem, and we calculated individual parts going through second derivative and first derivative and so on, and we try to combine them together. So let me show you the bottom of it. So we got this answer in here. So remember, these e to the 2x and cosine 3x is a part of the polar form of a complex numbers. So it's actually interesting to put this one into complex context and pull out some magic. It is a little bit more efficient than this one, but not a whole lot, but it's still fun to show, and maybe some of you prefer to use that method. So we're going to do exactly the same problem, except this cosine I will change the sign, but it's a very similar problem, and use complex numbers to pull out some computation slightly done more efficiently than this.